Hi, my name is Ciera Hudson, and today I'll be talking about the Physics 2212 Lab 1. In this lab, we were expected to determine how much excess charge or deficiency of charge is on one piece of clear tape. First, we conducted an experiment by transferring charge between pieces of tape and determining if the tape was positively or negatively charged. Then, we were expected to create a glow script model to find the amount of excess charge on the tape once we determined that it was negative. An additional objective is that we will be answering reflection questions to further our knowledge of this subject. The first step in the experiment was to create a charged piece of tape by sticking it onto another piece of tape on the table and then pulling it off very quickly. This caused a transfer of electrons. We were then able to determine if the charge on the piece of tape was positive or negative by rubbing it against a plastic pen. We knew that this plastic pen was negatively charged and that the tape was repulsed by it, so we knew that the piece of tape was also negatively charged. The second part of the experiment was to create two pieces of tape that were charged and then analyze the interaction between them. The first piece of tape would be suspended horizontally between two vertical objects with a little bit of slack in between. We would then create another charged piece of tape and hold it underneath the first tape, moving it slowly upwards. When the upper piece of tape began to float, we would record the distance between them. Several fundamental concepts were utilized in this experiment. The first one was Coulomb's law, which allowed us to analyze the electric interaction between particles. The second one states that the force of the electric field is equal to the charge of the particle times the electric field. And the last equation says that the force of gravity is equal to the mass of the object times the gravitational acceleration. Several relevant constants were used, including gravitational acceleration, which is 9.81 meters per second squared, Coulomb's constant, which was 9 times 10 to the 9th, and the charge on one electron, which is negative 1.6 times 10 to the negative 19th coulombs. There were several assumptions and initial values that were considered when making the glow script model. The two assumptions were that each U-tape has the same net charge, and that each tape would be treated as if all of the charges were located at a single point at the center of the tape. On the glow script model, it is shown visually as one point. The initial values that were used were the distance between the two pieces of tape when the top one began to float, which was 1.5 centimeters or 0.015 meters, the length of one piece of tape, which was 9 inches or 0.2286 meters, and the mass of one piece of tape, which was found using the length and the density, which was found to be 0.0002286 kilograms. This is the code that was used in the glow script model. The two objects that were created were tape 1 and tape 2, used to represent the two pieces of tape in the experiment, though they are represented as particles in this model. The first initial value that was created was the direction vector from the bottom piece of tape to the top piece of tape, known as R. We were then able to use Coulomb's law to find the charge on one piece of tape, and then use the second equation from the last slide to find out how many electrons were actually present on that piece of tape. Here you can see the visualization of the glow script model. The blue sphere is used to represent the upper piece of tape, while the red sphere is used to represent the lower one. There are two equal and opposite force arrows on the upper piece of tape, showing the gravitational force downward and the electric force upward, which is the repulsion between the two pieces of tape. The results that are shown from the glow script model tell us that the charge on the piece of tape is 7.4876 e to the negative 9th coulombs, and that the number of electrons on the tape is 4.67975 e to the 10th electrons. Through this experiment, we were able to determine that the charge on the piece of tape was negative, which means that there is an excess of electrons. If the tape was positively charged, it would mean that there was a deficiency of electrons. The charged piece of tape would be attracted to positively charged objects and repelled by negatively charged objects. Instead, we were able to see that it was negative by being repelled by the negatively charged plastic pen. We were also able to determine the charge on each piece of tape, that was 7.5 10 to the 9th coulombs, and the number of electrons on each piece of tape. There were two conceptual questions that we were asked to consider in this experiment. The first one is, what if electrons had positive charge and protons had negative charge? Well, in this case, the tapes would still repel each other because they have the same charge, even if it was positive. Only if one tape was positively charged and one was negatively charged would they attract each other. The second question was, why is it important to handle the tapes as little as possible? This is because electrons transfer by contact, and touching the electron with a hand will make electrons transfer to your hand and change the number of electrons on the tape. This will change the data, which means it will be less accurate to determine how many electrons are on after charging it. Thanks for listening.